Hi, today we are looking at section 10.3, which deals with ellipses. So we get ellipses by expanding or compressing our circles by different amounts in different directions. Now, a chord of an ellipse refers to a line segment adjoining any 2 points on our ellipse. Our longest chord is our major axis. Now, it doesn't have to be one particular direction. So for example, if our ellipse looks like it's stretched vertically, our major axis would be vertical. If it looks like it's been stretched horizontally, our major axis would be horizontal. So this would be our major axis, and this would be our major axis. The shortest chord is referred to as our minor axis. So that would be across here or across here. Now we'll look at a couple different forms of equations. So standard form of an ellipse centered at 0, 0 is x squared over a squared plus y squared over b squared equals 1, where a cannot equal 0 and b cannot equal 0 because we are unable to divide by 0. The x-intercepts are at plus or minus a, and y-intercepts at plus or minus b. The horizontal axis itself has a length of 2a, and vertical has a length of 2b. And our domain would be from negative a to positive a, and range from negative b to positive b. And then if we modify this to include horizontal and vertical shifts, our equation will become x minus h squared over a squared plus y minus k squared over b squared equals 1, where h and k are horizontal and vertical shifts. So we have this equation, an ellipse is described by the equation 16 times x plus 2 squared plus 9 times y minus 5 squared equals 144. We're going to write the equation in standard form and identify the center of the ellipse, determine the directions and lengths of the major and minor axes, and sketch out our graph stating our domain and range. So first thing for part A, I'm going to rewrite our equation down here. So we've got 16 times x plus 2 squared plus 9 times y minus 5 squared equals 144. Now in our standard form, this equals 1. So what we'll do is divide every term by 144. So our next step will be to reduce these to lower terms. So 16 over 144 is 1 over 9. So we've got x plus 2 squared over 9 plus, we reduce this to lower terms, it becomes y minus 5 squared over 16 equals 1. So this is in standard form. Our center, we can get just like our center of our circle. So it'd be at negative 2, positive 5. Now, our larger denominator will match up with our major axis. So our major axis is going to be on the y-axis. 16 is equal to b squared, so therefore b is equal to 4. So we have a major axis, which is vertical and has a length of 2 times b, so a length of 8. Our minor axis is coming from this 9. This 9 is our a squared, so a is equal to 3. So our minor axis is horizontal. And it is 2 times a, so 6 units long. Okay, so to sketch this out, I'm going to start by drawing where our center is. So our center is at -2 for x, 5 for y. And then we will look at our a and b values. So our b value for this was 4. So that's how far we go vertically above and below our center. So I'll mark 4 units above, 4 units below. And then our a value will tell us how many units left and right of our center. So we've got 3 units, so 3 units left, 3 units right. So our ellipse looks something like this. Now our domain, we can see that we're going from -5 to +1. While our range goes from 1 to goes from 1 to 9. What you'll notice is you should be able to get these without even sketching this out, because we know, for example, the x value, our center is -2. We have an a value of 3. So if we go 3 less than that, we're at -5. 3 more than that, we're at 1. For range, we know we started with a center at 5. If we go 4 less than that, we're at 1. 4 more than it, we are at 9. Okay, for this example, we have an ellipse centered at the origin that was translated. It now has our equation 4x squared plus 9y squared plus 8x minus 54y plus 49 equals 0. We want to determine the coordinates of its center. So for this, we'll do essentially the same steps as we did with circles. So our first thing is to get our x values together and our y values together. So we've got 4x squared plus 8x plus 9y squared minus 54y plus 49 equals 0. Now our next step is to do completing the square with both our x values and our y values. One major difference is now we have coefficients in front, which we did not have with circles. So first step is to factor that out. So we've got 4 times x squared plus 2x. Then we'll have plus a blank minus a blank plus, we'll factor 9 out. So 9 times y squared minus 6y plus a blank minus a blank plus 49 equals 0. Now, in each of those blanks, we're going to do b over 2 squared. So in this case, our b is 2. So 2 divided by 2 is 1. 1 squared is 1. So we've got plus 1 and minus 1. This one, we have 6. So 6 divided by 2. Sorry, that's -6. So -6 divided by 2 would be -3. -3 squared would be 9. So we've got plus 9 minus 9. We'll now do completing the squares of these. So I'll add in an extra set of brackets. So we've got this perfect square trinomial here. So that becomes x plus 1 squared. And then we've got minus 1. Then we have plus 9 times, we've got the perfect square trinomial here, so factoring that gives us y minus 3 squared minus 9 plus 49 equals 0. We'll expand this out slightly, so we've got 4 times x plus 1 squared minus 4 plus 9 times y minus 3 squared, and then 9 times negative 9 would be minus 81 plus 49 equals 0. So simplifying things a bit, that's 4 times x plus 1 squared plus 9 times y minus 3 squared. And then if we have negative 4 minus 81 plus 49, that gives us negative 36 equals 0. So we've got 4 times x plus 1 squared plus 9 times y minus 3 squared equals 36. Divide everything by 36 to get this a 1. And we'll reduce to lower terms. So we have x plus 1 squared over 9 plus y minus 3 squared over 4 equals 1. So here's our overall equation in standard form. We, however, did not need to go this far to actually solve it. We could have solved it here, but it's always good practice to go all the way. So we can say that our center is at -1, +3.